Well, welcome to Fall 2023 KIN 346 Biomechanics. Looking forward to teaching this class. I haven't taught this class for probably about 4 or 5 years at this point. And the other courses that I teach are biomechanics of endurance performance and physiology of endurance performance. And so, but I've always enjoyed this class, biomechanics, as a class that captures really that starting place for a lot of people in terms of how to use physics, how to use mechanics to understand human movement. In particular, I'm interested in sport performance and even more so in endurance performance. So I hope that these next 15 weeks will be fun and you'll enjoy the way that I approach and teach biomechanics. I know a lot of you are probably hesitant about the math and the physics that may be taking place this semester. And there will be math and there will be physics, but I like to say that I teach biomechanics where it's not a math class and it's not a physics class. It's biomechanics. It's using mechanical principles to understanding human movement. And I'll mention this several times. There's biomechanics in all different areas, from dental work to working with different animals, elephant movement, goat climbing, dogs running. There's all sorts of comparative biomechanics. We're going to focus on human movement and biomechanics applied to understanding really sport performance. And so I'll give you some different examples on how biomechanics is used if you stay in the fitness industry and pursue a career related to kinesiology. So I hope it's going to be helpful. I hope you'll enjoy this. And I do have the Zoom rooms that will be open Monday, Wednesday of each week. As you're here in some of the other presentations, I open up each module on Monday morning, and then you can watch the videos and go through the material on your schedule. But I always will have the Monday, Wednesday sessions for video open, and you can get on and you can ask questions, maybe get a little deeper, dive a little deeper into the topic being covered that week. Those Zoom rooms, I do not have lecture material planned. It's all based upon questions that are being asked. And so I do hope that you'll take advantage of that. It is fun talking about this and really trying to learn biomechanics by applying it to things that we have interest in. All right, so I want to go over what's going to be in this very first module. And I have to remind you that you do meet for lab this week. I'll post an announcement for that as well. But this is the first week of class, and we want you to meet with the lab instructors to really just sort of get into the sense of what lab is going to be about. And biomechanic laboratories are all designed to help you understand lecture material a bit deeper. All right, so let me share my screen. Let me move this over here. And I'm just going to share the screen. And you have the Canvas page and you have the different material here. I have a video on the course logistics, which is just sort of explaining a little bit more about what to expect each week, where to find material, and so forth. I've got the syllabus here. You can also go to the syllabus link. The important parts are to look at the dates for the two exams that we'll have during the semester, and then also the final exam. Those exams will be done remotely, and I'll give you more information about those as we go along. Exam one will basically be on kinematics, the study of movement without regards to forces causing movement. The exam two will be focused on kinetics, both linear and angular kinetics. And then exam three will be cover the entire, the final exam will cover the entire semester, including things like work, energy, power that we're doing the last part of the semester. All right, so you've got the assignment, and I'll go through this in a little bit more detail. This is where you click on to see all the video links that you'll need to watch during the week. I did post a link to Biomechanics Handbook that I wrote. This is really sort of a short version of explaining things in text, and you're welcome to put that into a folder that you can access. So as we're going through material, you can go back and check how I write and explain things as well. I also encourage you to have some biomechanics textbook. You don't even need to buy one. You can check one out of the library. and just use any biomechanics book, because when I talk about kinematics in a biomechanics book, it's all going to be the same information, just different examples and maybe different symbols for equations that they use. Then I have some probably refresher material for some of you, maybe new material for others, how to approach solving word problems, and I'll go through this in more detail when we do come up with word problems. But again, this is not a math class. This is not a physics class. It's biomechanics, but we will need to do some word problems. Unit analysis, I go through that only because we do typically use SI units for the majority of parameters that we talk about. Every now and then I jump over into our standard units here in the US for things like speed, miles per hour, or maybe distance, where we talk about miles, because we can conceptualize how long 10 miles is. We may not know how far 5K is or 10K or what have you, simply because we don't typically do that conversion. But this is how to do conversions. I always encourage you to start trying to understand parameters in SI units. So know things like how tall you are, not only in inches and feet, but how tall are you in centimeters or meters? How much do you weigh in newtons versus pounds? Things like that. And then as we start talking about the parameters and the values that go along with some of the forces that we look at, you'll be able to contextualize what 1,000 newtons means. Is that a lot? Is that not a lot? And what have you. And I do have the notes here for the structure function performance lecture content that's in the assignment. Okay, so I'll be putting all the documents in the module, and then the links to the lectures are in the assignments. So this is assignment 1. Let me make this a little bigger. Assignment 1, and as I explained in some of the other videos you watch all the videos, read any material that's in the module, and then enter the date for when you watch the video. This actually helps me see how the content is being viewed during the week. And really the key is to keep up with these assignments every week. Just they're part of your semester grade. And the best thing to do is just right out of the gate at the beginning of the semester, just get in this mindset that you're going to watch probably about 2 to 3 hours of videos each week related to this class. What I also encourage you to do is start your own terminology worksheet. You'll see in week 2, I've got a terminology worksheet that I'll give you, and I'll have a video on that. And it's important to know the terms that are on that sheet. But there may be other terms that you'll want to know as you start watching these videos. And a learning strategy I encourage you to follow is, as you watch one of the videos, just have a little terminology sheet. You can print this one up or do your own, and just jot a term down. Maybe a term pressure comes up and you're going to say, oh, I want to check that out. And you can check it after watching the video, but write these down as you're watching the videos, and then go back and check the terms. And I got into this habit when I was doing my doctorate work, just trying to make sure that I was learning the terms and the phrases and using them correctly, and knowing the equations when I was in biomechanics that went along with each parameter, as well as the units. So it's just a good way to learn really the nuts and bolts that ultimately will show up on test material. So I've got the course logistics. I did put a video together. I've had this one up for a few years, where it's talking about my introduction and my background. Many of you may be in about the middle of your undergraduate degree. Maybe you're near the end of it. And I talk about how I left my undergraduate program and what happened after that. I didn't know exactly what I wanted to do when I originally left my program, but I talk about how I discovered this area and ultimately ended up here at UNLV. And I tell that story because I think it's important for you, as you're going through this class, is to be thinking about that next step. What do you want to do? I actually encourage students to go and look at job posting sites related to this course, biomechanics or exercise physiology or motor control or nutrition or whatever your area is, and start looking for that job that you really want to land in. And by doing that, you can start seeing what the requirements are for to qualify for the job. And then during your undergraduate education, you try to pick up some of those experiences and knowledge base that will help make you competitive for a job. Or maybe it's a graduate program, or maybe you want to continue into physical therapy or occupational therapy or med school or what have you. Look at what the requirements are to get into those programs, and sometimes you can make your application rise to the top by doing some additional work during your undergraduate days. I did put together a video for the syllabus. Always good to know the nuts and bolts of the course, graded elements, things like that. I have a introduction video to biomechanics to try to give you a sense of how I approach teaching biomechanics as well. And then I have a presentation on what I call the model of kinesiology, where I try to convince all of us that we're interested in human performance or how well we do something. But in order to understand that, we need to understand biomechanics, we need to understand exercise physiology, we need to know motor control, motor learning, we need to know nutrition, we need to know sports medicine, we need to know all these areas in order to ultimately understand how to help someone run a 5K faster, or maybe complete a marathon, or compete in whatever sport you may have an interest in. All right, so then the other videos I have in here, I do have a math review. Again, not to place an emphasis on the math, but to maybe help you remember some math rules that will be important as we go along. I talk about word problems, how to approach word problems, and then also the unit analysis to convert between different units. When we get to a test situation, I say probably 10% of my test, maybe 20% is some type of math, but a lot of times what I'm doing is I'm testing your ability to identify the right equation that goes with a parameter, or which parameter an equation allows you to derive, things like that. So I'm more interested in that part, or what units go along with a parameter, than sometimes actually doing the actual math behind using equations. I do have a presentation on structure, function, and performance. These are three unique parameters. Sometimes we mix them up, but we're really going to take a step back and say, here's what we mean by structure, here's what we mean by function, and here's what we mean by performance. I've used this term several times in this presentation. It's how well we do something, how fast we run a 5K, or how accurate we are in free throw shooting, or what have you. Whatever that sport performance is, that's one particular definition in this sort of trifecta of terms. I did put in a what I call an immersion video, and I try to highlight the immersion videos in this light gray in the assignments. When I highlight these light gray, watch these, listen to these, not with the sense that this is test material, but instead a sense of diving deeper into the topic, and listen for some of the biomechanics that it comes up in these videos. In this case, Dr. Jason Avedisian is one of our alumni from our PhD program, and he is the sports science director at Clemson University. And it's neat to hear him talk about how he went through his undergraduate degrees, then went into his graduate training, and ultimately ended up in this position. And he can give you a little bit of a sense of what sports science is about from that perspective. We may also have an opportunity that he'll be here in September, and may do a presentation in person, or you can log in remotely. We're trying to arrange that as well. But in any case, these are not test question materials. So I would never have a question like, you watched the video from Dr. Jason Avedisian, and how did he define sports science? Nothing like that, okay? These are, you're watching and maybe having lunch at the same time, or having your morning coffee, or what have you. Okay, so those are the videos. That's sort of getting our semester started. And then week 2 of Monday of week 2, module 2 will open. And then what we'll do is we'll start getting into kinematics, the study of movement. And we'll go through about 4 weeks of kinematics, and then we'll switch to kinetics, the forces causing movement. And then we'll go about 4 weeks of kinetics, and then we'll switch gears and we'll talk about some work energy, power, and we're talking about some movement analysis approaches, things like that. And then some other forces that are specific to, or not specific, but important to cover, like drag force and friction force, things like that. So we'll dive into kinematics, the study of movement, then we'll dive into kinetics, and then we'll do some other stuff related to biomechanics. Okay, I hope this is helpful for you as you get started in week one. Remember, attend your lab section in week one, meet your lab instructors and get the layout for what lab is going to be like for this semester as well. All right, thanks everyone.